So the previous example was a nice transition into discussing counting and the multiplication principle. Now, when we're trying to find probabilities, it's important that we are able to count the total possible outcomes because that's how we find our probability. Our probability is the desired outcomes out of the total possibilities. So, for example, a very simple example, if I had a bag of red and blue chips, there were 4 red chips and 6 blue chips, I would have a total of 10 chips, and I wanted to know what's the probability of picking a red chip if I randomly pick one out of the bag. So the desired outcome is what we're looking for. It's the number of red chips in the bag, so that would be 4. So 4 out of a total of 10. So when we calculate our probabilities, it's important that we know the total possibilities. That's why we're going to talk about how to count the total number of possibilities. And one way to do that is using the multiplication principle. So the multiplication principle gives us a quick and reliable way to calculate how many total outcomes there are when we are picking choices made in a sequence or from groups. So if one event has m outcomes and another event has n outcomes, the total number of outcomes is for both of those events to happen is m times n. That's the total number of possible combinations. So in part A and B, we're going to use the multiplication principle. So a footwear store offers 5 styles of boots and 4 colors. So if we want to know all the possible combinations and how many different boots that are possible to buy, we would take 5 styles and multiply it by 4 colors. And we would get 20 possible choices for boots. For part B, we have a smoothie bar that offers 6 fruits, 3 liquids, meaning like what kind of milk you want, almond or coconut, and then we have 5 toppings. So if I want to figure out how many possible smoothies can be made, what are the total possible choices? We would take 6 fruits, multiply it by 3 liquids, and multiply by 5 toppings. That would give us 90 possible smoothies. Now, part C is a little bit different. In parts A and B, we counted all the total outcomes by multiplying the options across the category. But in part C, we're going to be still counting outcomes, but the situation involves what's called overlapping groups. So we're going to have to take a different approach. Now, in this example, it says a library has 60 books in total, and among 35 of them, 35 are mystery books, 28 are hardcover books. If 12 books are both mystery and hardcover, how many books are either mystery or hardcover? So those 12 books are in both categories because they are both mystery and hardcover. So the same 12 books are in the 35 that are mystery, and they're also in the group that's 28. So when we want to count the total number of unique books, we need to make sure that we don't double count those 12 books. So we're going to take 35 mystery books, and we're going to add it to the 28 hardcover books. However, the same 12 books are in both of these categories. So, in the 35 mystery books and in the 28 hardcover books, we counted those 12 books twice, and we don't want to double count because that will give us false information. So I'm going to subtract 12 of those books so we don't count them twice in each of those categories when I add them. So the total number of unique books when we take the 35 and the 28 and then we subtract the 12 is going to give us 51. So when you're looking at categories that overlap and you're counting, you want to make sure that you subtract off anything that you double counted.